Yes. Cool. So we are live, and I'm going to change the title because we're not tackling database today. Today we are actually developing syscalls in our VM written in Objective-C.
This will be the day we've waited for.
No, not yet. The day I'm waiting is the compilation day.
Oh,
I'm
that
waiting
was a
for that.
reference, by the way.
Yeah, yeah, probably from a lot of movies. Uh,
From Ruby, actually, the web series, which
okay,
became an anime, oddly enough.
I didn't know that. So how did I envision this? I envision making a new category, right? Why a category? Because we want to have access to the internals of the VM, but I
Yes.
would strongly advise for the separation of syscalls because we're gonna have a lot of auxiliary functions. Maybe like one major function, which is the syscall operation, which only is gonna require one opcode and is gonna take one argument from probably the data stack. And then we're going to have a bunch of auxiliary functions handling each one of the syscalls. So that's going to be really, really neat and nice if you make a different category. So what do you think of that?
Sure, we can go with that.
Cool.
I
So
don't see any problems.
we're gonna make a file called vm plus syscalls.h. And every single time we do stuff like that, I say, dude, we are putting a plus in the name of a file. That's kind of cursed. Um,
I mean, like, if you think about it, um, that's only weird if you're coming from Windows, probably. In Linux, it's like, yeah, you can have whatever you want in the file name as long as it's not a slash or a new line, you're good.
In here, we only have gonna have one function, which is gonna be the instruction syscall, right? And again, I believe this is the file that we declare the public stuff, right?
Yeah.
Um, so in here, we actually gonna have only this one because that's the only one that we're gonna export. And in the implementation file, which is gonna be vm plus syscalls.m, we're gonna have a different kind of thing. We're gonna have something like syscalls, like that.
Oh yeah, I think the extension for Mercury actually is .m because that's the website's fav icon. It's a .m.
I see, I see. Uh, so now I'm gonna delete all the crap of the previous file because I copy pasted. I should have done the smart way of doing that, but well. Okay, and then this is gonna be the instruction syscall. Maybe that's a little too okay. Now it seems better. So the first thing that I think we should do is to go to the header file, and we're gonna create an opcode of syscalls in here. Right. We're gonna create we're gonna create something like this. Right. And then in here we're gonna consult the table that I hope you already have open there.
Uh, the,
Syscall opcode. That's gonna be the name of this. Cool.
which which table? The Plan 9
Yeah,
one,
the
or
plan
do you
9
want?
one. We're not gonna actually like implement that today because we're only gonna implement that when we compile the syscalls. So it doesn't really matter. I just want to know which ones we're gonna have to interpret today. Actually, we
Okay.
should decide. Ideally we should have decided which assembler we're gonna use. So like FASM, NASM, Plan 9. But I believe most of them should have the same sort of set of syscalls, so it's fine.
Um, yeah, I'm pretty sure. I'm not entirely sure how syscalls are handled in x86. I think they have an instruction that's similar to what we're doing, where you pass a number, and that number is the syscall you
Yeah, yeah,
want
they have
to
that for sure.
execute.
I can guarantee you that. I watched Zozin doing that multiple times.
Okay. Well, in that case, it should be fine, I think.
Yeah, but it's gonna vary from assembler to assembler. Like maybe the syscall one is not gonna be the same for all of them.
Actually, for Linux, it is. I'm not sure if you're aware of this, but in Linux, the syscall interface is actually considered a public interface, and it's guaranteed to be. They promise to make it stable. So,
Okay, so we probably should go with that.
okay, but then that's a different table from the Plan 9 one, and I think it's a much larger table as well.
Yeah, but we're not gonna implement all of them. We're gonna maybe implement a subset of them. You can send me
Sure,
the link as well, please.
but let's see. Um, okay, apparently there's a man page for syscalls on Linux. I don't think it has
Actually, let me
the.
try to Google that. Maybe that's not unreasonable. So like Linux
Uh,
syscalls table. Yeah, this is the table that Zozin used for multiple videos, I believe. Yeah, this is definitely a table that he uses all the time.
yeah,
Okay,
and they are actually numbered, which is
yeah,
useful as
that's pretty
well.
useful. So which one of these we want to have? So like I don't know all the names of or like what those names mean. At least not all of
Well,
them.
if we cross-reference that with the Plan 9 syscalls, and I'll send you the link because it's a handy one to have. We can look at what Plan 9 uses because like they have a very small syscall interface that provides for
Have you
basically.
thought that like compiling this would be a lot easier than just like interpreting it? Because in compiling, we only would have to take a look on this number and it's done. Like just call the syscall instruction and passing this number as an argument and it's done. Interpreting, we're gonna have to know how to do these things in Objective-C.
I mean, those are C functions, so we should be able to just call them, right?
Oh
And
yeah,
then we
but
would
it's
have
still
to
a lot
talk to
more work
the.
because it's not only like calling a built-in function instruction and going with that.
Well, I mean, we just have to check the number. Uh, oh, right, because we don't actually have the direct. We're not actually emitting the instruction directly. We're just calling a C function that calls the syscall for you, which means we would have to do a lookup table or something.
Yeah,
So yeah, that's.
it's gonna be worse. And missing. We are missing some things in here. Like where is the std out?
Std out is literally just a file descriptor. You use the
Oh
same
yeah,
syscall.
in syscall it is done like that. I forgot. It's considered a file, right? That makes sense. It's considered a file actually. Cool.
And that's why the Plan 9 interface is so narrow. They take that idea of everything is a file and they make everything be a file, unlike Unix, where some things are not actually files.
I see. Do we know, like for instance, if you do a write, what do we put in order to like to call to say that the std the out the out device is gonna be the std out.
Well, traditionally, the file descriptor number 0 is std in, number 1 is std out, and number 2 is std error.
I remember that, but it would be nice to like to see that in the documentation. It would be kind of nice. Oh well. Okay, so which ones we plan to do today? I think like read and write. I think those are fine to
Mhm.
implement today. That those are basically these two. There is some documentation, which is cool. Oh yeah.
That's
Oh yeah,
literally
it
just the
comes.
main page. Yeah.
Yeah, but it comes with. Yeah, this is although this is very old, this is very useful. like It has a bunch. It's very descriptive. I really like that. So this is the function that we can call in. Maybe that's a better thing to do instead of doing what I thought, because what I thought would be to like, if you grab a number one in the case of x86-64, you're gonna do a write, and then if the write argument is true, we're gonna do a printf or an nslog. But maybe it's actually better to call the function in the manual. I don't know the
Yeah.
trade-offs of that.
Well, the trade-offs are
Well, the
um,
the upside is that this is already documented for us.
yeah, that's definitely true. The problem is,
Oh, we're gonna have to add a dependency though.
well, yeah, but isn't libc? I wonder, is libc a transitive dependence of the Objective-C foundation?
That's a very good question, which I have absolutely no idea of the answer.
Because if
Uh,
it is, it's not a big deal, and even if it's not, I'm not sure that's a big deal either. Because like it's libc. Why would you like?
yeah, and the next question is that I'm pretty sure this is the size of the thing that you want to print. Um, this is the buffer, I believe, and this is the actual output device. I'm pretty sure. So writes
Yep,
up to count bytes from the buffer starting at buff to the file referred to the file descriptor fd. Right. The number of
yeah.
bytes written may be less than count. For example, there is insufficient space of the underlying physical medium. We don't care about that. I only want to know what do I put in fd to say std out.
Uh, it's the file descriptor. For std out, it's one.
Where are you looking?
That's actually a POSIX thing.
No, yeah, I believe you, but I would like to see it in the documentation. I remember one being the thing, but I would like to see that. Very weird it is not in here.
Here. Um,
Very, very weird.
I sent I sent a link in the chat.
I saw it. Yeah, so std out is number one. Yeah, I believe you. Again, that makes total sense. But why is not in here?
Because it's probably somewhere else in the documentation. This is the documentation specifically for write, and write doesn't really care which file descriptor you pass it, as long as it's actually, an actual file descriptor.
Okay, so let's actually. Oh man, there's gonna be a lot of opcodes for that. Like this is one sub opcode. Um, okay, so let's start with let's put read as the first one for sure. So syscall write. Let's see that this is number one. That's cool. Then we're gonna have another enum, which is gonna be pretty similar to this one, which is gonna be the write device opcode maybe. That sounds like it's kind of reasonable. Let's sort this thing. Let's put all of this in there. Of course, it's completely nuked. And then in here, we're gonna say something like this. Then we're gonna say that this is number two. There. And we are missing a comma. And this is gonna be number one. It would be nice to be like that. Okay. So let's start by doing the right first. I believe that's an okay idea. So let's first implement the main function, right? So the main function, how the heck are we gonna do that? So my understanding is that we're gonna pop the syscall, right? So this is gonna be basically the syscall value. Actually, not the
Yes.
syscall value, the syscall opcode. Syscall opcode. And now it comes the question. Let's suppose that that this syscall opcode is the right one. Where the heck is the data of the buffer that we're gonna have to read, right? Where are we gonna have that? Maybe
Um,
that makes sense to be on the data stack.
oh, the data stack would have a pointer to the buffer. The problem is that pointers in the data stack are pointers to the virtual memory of our virtual machine, which, as you recall, actually contains references and not actual, you know, bytes, which is a problem.
Can't we just dereference them? Like what you're saying to me, I think, is that you're saying that this is a syscall argument, and then you're gonna do the same kind of pop, but this is an address, right? So we would have to dereference that, but we can't because we have access to everything in the VM.
Yeah, the problem is that the VM memory is not just a simple bytes array. It's actually a mutable object array, which means it has identif well, it has references instead of literal data, which means we can't use it directly. We would have to like for each syscall, we would probably have to have some kind of wrapper around it that translates the memory of our VM into like actual native buffers and such
I
that the
am
syscall
very,
can.
very confused. Why can't we just s access the memory? I think it's memory RAM. Why can't we just access that using this as an index?
Uh, because the memory RAM is not just a plain array of bytes or array of uints or whatever. It's actually an array of references, and the references themselves, um, I'm pretty sure that most of them will be like, hmm,
I'm really confused. Everything is an array or a stack of references from the start. Everything, because Objective C
yes,
apparently doesn't like to have differently. So why
yes.
in this particular case wouldn't it work?
Uh,
Let's do the following. Let's do
well,
the following. So instead
we
of
can
doing
try it out,
anything
I guess.
else, yeah, exactly. We can just do
But
nslog.
my main worry is that we are operating on the premise that we want to be 32-bit compatible, and we even have like a 32-bit wide word in the VM, right?
Yeah.
Kind of. The
Okay,
problem is that
and this we're gonna
we,
exit with, I don't know, this is not assembly, this is a function with true, whatever.
instead of exiting 2, we would push a 2 or whatever the return value is on the data stack.
I
Oh,
have no
never
idea what
mind.
you're talking about. This is just to break it. Like the
Yeah,
program
never
will
mind.
fail.
Yeah, no, never mind. I'm thinking way ahead. I need to put my feet on the ground. Yeah, the problem is that
And you're gonna
we
have to add a
generally
new thing here as well. Go on.
we generally will have 32-bit values, but because the memory is implemented as an array of references and you are running a 64-bit machine, we are actually only using like half of the memory. And it's not half in the sense of, oh, I'm using the upper half or the lower half or whatever. No, it's kind of like stripes where you alternate two colors. Like
Oh, I think I know what you're talking about.
Yeah, we're essentially alternating between zeros and actual 32-bit values because they have to be padded to a 64-bit length because that's the length of a reference in a 64-bit machine.
I see. So we probably need, yeah, we probably need something like syscalls in here.
Alternatively, hear me out, we could like replace the memory with a proper array of uints of 32 bits width. That's an option. But
What are
then
we
we would
using
have
to do that though?
we're using
Oh,
an
we are
NS
using
mutable array.
it's being like done automatically via the my system. So it's using 64 automatically.
Yeah, because you are compiling the program to your native architecture, which is 64 bits wide. That's why the reference is 64 bits wide, and that's why you end up with the striped memory thingy I mentioned.
Yeah. So I completely forgot that this is being done automatically via my architecture. That's kind of
If
sus.
this was being run in Mageta's Mac Cube, we wouldn't have this problem. But we're
Instruction
not.
syscall.
We're
Instruction
running on your
syscall.
machine. So
So actually, that's a good time to see the development process because we're not doing like compiler assisted. I'm just doing it by memory. Uh, so I already added to the evaluator, and now it's just a matter of adding to the parser. And the parser is already embedded with Alexa, so we don't have actually to like go to the tokens and to the stage of building it,
we just have
which is kind of
to.
interesting.
You already added the opcode to the enum, right?
Yeah, it's just now I also have to add it in here,
Yes, in the
like
dialect.
syscall.
Yep.
And I don't know which changes we need to do with the parser. I'm actually really curious to see what the heck is going to happen. So let's see.
We shouldn't need any changes, I think.
Um, yeah, that's really interesting. That's really interesting. The parser just obeys whatever is in the opcode and whatever is in the dialect, and it just works. I wasn't expecting that.
That's the power of making our functions data driven.
I was not expecting that. Okay. Well, to be fair, we are not adding something that is completely and utterly with a different kind of instruction, right? We don't have to have a
No.
special symbol. We don't have to handle any of that. So it's just simply another instruction. So it should be
Yep.
fine.
Yep.
So let's actually do nix develop. Oh, that's not the thing. It's nix run this chime. Okay. So file not found. I have a feeling I know what that is about.
We need the
We need to
header
add the file in
or
here. So chime, which is kind of annoying. Kind of annoying. But I mean, it is what it is. Maybe there's definitely a better bash ways of doing this. I know that for a fact. But for now, I think just
let's
copy
be
pasting
Grug.
is fine.
Let's be Grug.
Um, that's very interesting. No such file encountered. And did I mistyped? Syscalls in plural. That's very interesting. Oh yeah, I know what this is. It's a stupid bullshit that Nix requires you to have to add the flick in here. No, it's not. Okay, that's unexpected. Let's actually see
Oh,
the
I
log.
think you may actually need to commit the change.
I don't think you need to
Maybe.
commit. You just need to stage. No such file. VM plus syscalls.
Because that's a new
Uh,
file, right? The repository is not aware of it.
No, but I don't think that
So
matters at all. I'm really thinking that I need to stage the files because they were not created. They're not being tracked. So let's actually do that. So headers, no, VM plus
just add
syscalls.
just add. Oh, wait, but the opcode, right? Oh, you probably want to.
That's not what I want. Okay, so let's just stage everything. I think that's what you want to say.
Yeah, basically.
I really hate this mechanism that the Flake uses. Okay, I missed a comma. That's fine. Uh, and I really don't understand why my Emacs is trying to indent this thing as like weirdly. Maybe it's because it's configured to use. No, that doesn't make any sense because this is not indenting at all. So it's just going crazy. Oh yeah, now we need to do this every time because of the flake limitation bullshit. Okay, so theoretically we should have. Yes, we do have. So if I do result bin and then chime, this should complain as expected, which means that it's time to actually make a sample. So syscall um, write syscall GHF. Okay, that's pretty cool. So let's actually go to something like sum. Yeah, let's do something about this. Let's actually do something about that. I already identify. I did I identify a problem? Actually, did I identify a problem? That's very interesting. I don't think. Wait, let's try. So main literal syscall one.
Uh,
Yes, and
the
then we
one has
want
to
to
be in
do
the next.
something like
The one
uh,
needs to be in another line.
write syscall um, write syscall, and then we're gonna say that the write syscall is actually um, this is not this is write syscall device, right? And which device do we want? We want one.
Yeah, the number one has to be in the next line because like if you try to put it in the same line, the parser is gonna complain because
Yeah, I feel it.
the the number constant is a full word and you're in the middle of a word of instructions, so that doesn't fit. So
Actually, this is also kind of wrong. Yeah,
why?
because this is also a literal. Because this is a stack machine, we need to push the arguments first before calling the thing. I was doing
That is true.
x86 style, putting the one in here.
That is very true. You are
uh,
correct. You are learning.
I was doing x86. Okay, so we are putting two literals. Yeah, but in that particular case, this is not a reference at all, right? This is not a reference.
No, it's not.
Oh, so that means we are missing a thing, right?
We need a
Because we should
reference.
we need to add something like um, um, write syscall content, right? And then we're gonna have to do something. I don't remember the symbol anymore because I suck. So what is the symbol?
Um, by the way, your arguments are backwards.
My arguments are backwards. What?
The syscall is gonna look at the top element to figure out which syscall you wanna call, but you are passing the syscall
Oh yeah,
content
that's true.
pointer
That's true. That's
to
true.
the
Yeah, but that's minor
top.
details, I think, for now. You're saying that it should be the kind of this, right?
Yeah.
Yeah.
Now
So
it's correct.
yeah, but now we need to remember what is the syntax. I already forgot. What is the syntax? I think I remember. So it's gonna be like write syscall device, but then we are fucked because we don't have string literals. This is not device as
We
well.
actually really have a more annoying problem, actually.
So this should be like
We
hello world. Go.
Yeah, we could cope without string literals in general, but we would need to have byte addressability. Right now it's annoying to construct a word which is meant to be interpreted as like a sequence of characters because ideally you want to write the characters, right?
Yeah.
But we would have to write a number which is very annoying.
Yeah, so maybe we should add support for string literals. How hard
Uh,
that's gonna be, I have no idea. Um,
well, first
I
of all,
actually,
string.
yeah, but before you say anything, let me just fix a thing. So this is actually kind of wrong, right? This is actually kind of wrong because no
Uh,
function, this is the main function, this is the entry point of the syscalls. Nobody's gonna be doing this at all. Here we're gonna have some sort of like an if of sorts, and then we're gonna do
for
the same kind of trick that we are doing with the opcodes in the other file, and then that function of the write, that's gonna be doing these operations that we are doing here.
Yep.
So we're gonna have to do something along the lines of. So let me check how the heck I did that before. So we already had this demand before. Oh, it was in the parser. Yeah. So how do I make functions? Oh, it's just the same syntax but not declared in the header. Okay, that makes sense. So let's say that I want to have a void like a syscall write. Yes, I want to have that. And then in here, then I'm gonna do this crap here. But I also need the try catch because we're gonna do a bunch of pops. So there is that for sure. And then we're gonna do these things in here. Then we're gonna be doing these things. Then before that, we need to go into the VM. We need to actually go to see how the heck we are doing that. Okay, so it's gonna be something like this as well in here, which is kinda interesting. It's kinda
Uh,
Hello,
interesting.
Maggie.
hello.
Hello, Magetta.
Uh,
Hello, hello. And then
You
in
sound
here, we're gonna
exhausted.
do something like
I am, man. I couldn't sleep well yesterday, and I stayed today all day debugging stuff and coding JavaScript. I think that this.
JavaScript.
Yes, we're like integrating CI thing to run tests, right? Automated tests. So that's like JavaScript basically. So yeah.
I see.
Why use JavaScript for that?
Because it's a testing library. Not a library, sorry. There is this
We are live, so
company-wise.
be careful, Magetta.
Yeah, yeah. There's this like company
Do
thing
not
that is like
get
JavaScript. It's like
implemented.
another project from another team that they do in JavaScript, and then we have to support our system in there. So it's JavaScript.
Okay, I think the
I
code is
see.
not ready, Marin. So let me actually put Magetta into what we're doing. We are implementing interpreting of syscalls. So we already
Mm-hmm.
made a file with the opcodes for the syscalls that we aim to implement today. Maybe we're gonna actually put the open in here as well. So syscall open, I believe that's
Oh, by the
true.
way, I already have a Lisp that compiles to .NET, and I can target Chime now. It's just buggy, so
Oh,
that's the
okay.
problem.
I was about to say that was fast.
No, I
Uh,
mean it works. I can add, I can divide, I can print.
oh,
The
so
only
it's like
problem,
That
systemf.
no, like I cannot declare like I, for example, if right now if I declare a lambda, I cannot load the arguments. I discovered the issue this afternoon when I was talking to Victor, but
You did it in
um,
F sharp?
yes, it's F sharp. But well, I made a terrible mistake because I made immutable. because I needed a global state, and I said, ah man, like I'll just do it mutable instead of passing the same thing like to change, and then it
Wait, you did
now it
immutable or mutable?
I did mutable.
Oh, okay.
So
I heard
I have
immutable.
a I have a mutable record. So I have to update the record. Man, it's
Yeah, that
terrible
sounds bad.
decision. I
Sounds
should
bad.
not have done that.
Yeah.
Because now I have like hidden state I don't know how to find. It's terrible.
Yeah.
Anyway,
Okay, so what we are doing right now, we are trying to understand, we are trying to establish how the heck we're going to read arguments from the chime to go with to this piece of code here, to this breakpoint here.
mhm,
And we just discovered, Marinho and I, that we don't support string literals, right?
right.
So how in the heck we're gonna do that? So the syntax is gonna be pretty much like this. So this is a reference to the buffer that you're gonna add to that you're gonna use as an argument when calling the syscall. This is to which device you're gonna call the syscall with. In our case, it's gonna be stdout. And this is the syscall number identifier, right? Um, so, but then we don't have this. This doesn't. It isn't. We are not able to parse this. So Marinho was about to say something about not having to
Yeah,
have string literals.
we have a. I mean, we can have string literals, or we can cope without them. The problem with implementing string literals in the current parser is that it's going to be very finicky about the line numbers because a string literal may span multiple words in memory, right?
Yeah.
Which means that suddenly we don't have a mapping, a one-to-one mapping between lines in the file and memory addresses anymore.
Oh, that was because everything was just we were just using numbers before.
Yes.
So I see. I see. Okay, so that's bad, right? So again, we are learning this for the second time. We should not depend on new lines for anything at
What
all.
we can do, what we can do is basically cheat. We could say that, okay, if the first character of a token is a double quote,
Oh man.
you
Oh
instead of
man.
you
This
interpret it as a number, except you build the number by reading the next whatever characters. Like
Am
you
I
basically
getting?
parse a string that's up to 4 characters long, essentially, and you pack it into a word, and then
Oh, but
we have to
that's
break
so
up
bad. Like that's bad, right?
why.
Because you're basically allowing only strings with 4 characters because that's what fits in a
No, 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 no,
word.
no. It's not. It's not because It's not because I'm limiting the length of the overall string. I'm just limiting the length of the chunks that we can write in each line because
Yeah,
each
no,
line
yeah.
has to
I'm
correspond.
not. Yeah, yeah. You said it right. I inverted the cause and the consequence, but you said essentially the end result is the same because of a limitation of the word thingy being 32 bits. It needs to be 4. If it was 64, it would be eight characters, which is still terrible.
this made me remember that worse is better. By the way.
No, no, but like if you need to have a pointer to a string, what you do is you point to the beginning of the string, and you also need to have the length of the string as a separate value because you need to know how many characters you care about, right?
Yes.
Um, and then the string itself, you just write the words in memory one by one, like 4 characters at a time.
Yeah, but wouldn't
Uh,
that break the correspondence between lines and
It
and memory
won't
slots?
actually. It won't
I have no idea why. You just said.
because because each chunk is 4 characters long. Each character is a byte. We're doing 32-bit words, right? So 4 bytes per word.
Yes. So look at this example. 4 characters is this, right?
Yes,
Yeah, so we're gonna write each byte and put that in a word and put that in memory, right?
yes.
So then we're gonna have one, two, three, four again. So these are the next. So this is another word. right?
Yep. And
Yeah,
we
so
will
it's
probably
already like one line is consuming 2 words, right?
no. Now you have to put a new line between them, and then the next line you start the next memory words.
You gotta have to put a new line between them.
Yep.
I have no
No,
idea why.
not like that. Not like that. I'm talking about like just press just press enter. Now write the double quote at the beginning of the line, obviously.
Uh-huh.
Now press enter there after the O in world and put another yes. 1, 2, 3, 4, and
Oh,
that's
yeah,
basically
that has 5, right? Oh, no, 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 sorry, 4. That's
Yeah,
right.
that has 4.
yeah, and
Uh,
that's basically our strategy.
so every single time, I'm still terribly confused how that's gonna work. So let's suppose that I'm parsing this. So this has the column, which means that this is a label, right? So this is
Yep.
a label that you can reference using the E for address. And then if I encounter a string, I'm gonna divide that into chunks of 4, and I'm gonna put that straight up into memory. How the heck am I gonna read that afterwards?
Well, we would have to do bit shifts to access individual characters because we don't have byte addressing in our machine in our VM. Um, but then the pointer at the beginning of write syscall context, it's pointing to the beginning of the string, and you can just iterate from there.
Yeah, that doesn't answer my question. So let's suppose that the string starts here. When I'm
Yes.
reading that back from memory, how do I know it stops here?
You would have to pass a separate value indicating the length of the string. Um,
I see.
Either that, or you can do what forth does and just put the length of the string as the first word of the string itself. So
Okay,
like,
okay. So here's my pitch. Let's not print strings today. So this is gonna be 69.
Here, here's a question. Like, why are we talking about separating into fours?
Be
I got it because it's space of an integer, but why?
No, I can explain that. So our memory, it's basically an array of 32-bit words.
Yes.
So if each character is a byte, Marinho was fitting chunks of 4 into each individual word of the memory. So it would look like this. So world.
Yeah, I that I got, but my question is, why is that being reflected on the parser?
No, that wouldn't. You would write normal thing. What the chunking that I was doing would be happening on the parser, in the parser.
So in the parser, you would have to break that, but the user
Yes.
wouldn't have to do
Yeah, the
it,
user
right?
wouldn't have to care at all. But we are already going through the into the implementation details of like the evaluator, how that's gonna look in memory, how we're gonna know what's the size of the string. So, for instance, the parser would have to count how many things
Mm-hmm.
it has between the quotes, right? And then it
Yeah,
would
I got it.
push the size. So maybe if this is 14. I have no
Mm-hmm.
idea. And then it would do the chunking. And then it would be pushing the chunks into memory. And then when we are reading that back, which I also don't know how the heck we're gonna do because we're gonna have to identify that this sequence is a string.
Mm-hmm.
Uh, and I have no idea how to do that.
that's the
Uh,
fun thing. Forth is actually, you know how C is weakly typed?
yeah,
Forth is actually untyped.
yeah.
So you don't actually explicitly identify that this is a string. You just pass it into a context that will interpret it as a string.
Yeah, but that's the thing. How are we gonna know that this is a context of a string?
Because we're passing it as an argument to the syscall, right?
Oh, so we're gonna assume it's a
Yes,
string. If it's a
essentially.
number, you're just fucked.
Essentially, yes.
Ah, I see. Okay.
Welcome to assembly.
Okay, not really, because as far as I can tell, x86, 64, like NASM, FASM, they don't have to do any of these things that we are talking here. Anyway, so my proposal is for today we just print numbers because this is already parsable, and then later on, if I have the steam, I during the week I can implement this sort of thing. This sort of thing.
That sure, that's a thing we can do.
Yeah. So this program should be parsable, right, Marin? What is on the screen right now?
It should be, yes.
And this is wrong. This is content. So just for everybody to be on the same page, we are pushing to the data stack the address of the value that you want to print on the screen. We are uh, pushing into the stack the value of the, basically pushing one using this as a label just to be a little bit
Yeah,
nicer.
yeah, that's the file descriptor for stdout.
Yeah, and then we are pushing the actual syscall identifier to be a write syscall, and
Uh,
that should
we could
work.
we could give that a name to make it a bit more like
Sure.
obvious.
Uh, so this is gonna be write syscall, and then here we can just do write syscall.
And the write syscall device we can rename to stdout, maybe.
Um,
stdout device if you want
stdout
to keep.
device. Oops,
Um,
there, and then we're gonna put it. Oops, put it in here. Okay, so this basically is how it should look like. I strongly believe everything's gonna be fine. I just want to see in here, not in here, in here. We need to actually do a little bit more things. So the first, let me actually put the program in here. So write syscall. So the first thing that we need to pop is this is already popped. This because this is how we identify that we need to go here. So now we need to pop the device. So this is a write device ID, and we also need to pop the content, write content, and that's what we're gonna print in here. Write device ID and write content, and then we're gonna exit just to, and the program should just break. Okay, so let's see if it builds. It doesn't, which probably means that I did something wrong. It's saying the line.
you
Oh, there's an extra if here. Thank you, compiler. How do you print stuff? I always forget how to print the crap. Uh, how do you
lu
print?
maybe lu
Oh,
maybe
it's not
maybe.
A.
Oh, it's at okay.
Okay, so this is not opcode. This is syscall opcode. Okay, it worked. So now let's see. Bin Chime samples right, and then I'm gonna pass. What is the name of my thing? Yes, key key keywords. Boom. Um, 1 and 4. 1 and 4. That's very interesting. So what the heck? Let's count. So the first thing that you're gonna print is the write device ID, which is 1. That's nice. And the write syscall content. I think that's kind of wrong.
Actually, no, it's not because that's the fourth word in memory, and we are passing a pointer.
1, 2, 3.
No, the
These are
first line is
compiler things, so this needs to be 4.
no. Yeah, no, the first line is word 0, and then we have 3 literals. So 1, 2, 3 are accounted for, The next word that actually goes into the program is the right syscall content label, right? Which is on address 4. So it's the correct pointer. We just
Okay.
didn't, we
Okay.
just,
So that's progress. That's really that's progress. So let just for me to see if I understood. This is the device. So we're gonna have to do another if in here using this. And we also have the 4, which is the address to this. And this is 4 because 1, 2, 3, 4. Is that how you count that?
actually the first line is address 0.
This.
The next line is address 1, and then
1.
2 and 3.
Oh,
And
these
then we
are
skip the,
eliminated.
yeah, we skip the empty line, we skip the compiler constants, and then line
Oh yeah,
number
these
4.
the 4 is in the file. This is the line number. It's not the position in memory necessarily. Okay, I need to remember that. Okay, so now we're gonna do the if that I just said. So we're gonna do write device ID is equal to, and then in here we're gonna have to, yeah, we're gonna have to
1.
grab those things. We're gonna have to grab those things. So the first one is gonna be sdin file no. And by the way, Mageta, these names came from the the manual, the Linux manual, I think.
Okay.
So we grab those from there. Oh no, these specifically came from this post. So because we plan to use the documented syscall. So this is the C function that actually calls the syscall. We're gonna pass
Uh,
this, and this. And I asked Marinho, how do you know what is the identifier of the file descriptors? And he said, you don't. You need to Google that. That's
yeah, it's
Actually,
just oh, but
Actually, what
well,
I said is that 0 is
0, 1, 2.
std in, 1 is std out, 2 is std error, and then anything after that you have to open yourself, basically.
Yeah.
yeah. But I complain that this is not written in here.
Oh, but somehow everybody that programmed in with using the Unix STD knows that. I don't know how the knowledge gets passed on.
Maybe it's a cultural thing.
Cultural thing.
Yeah, just maybe. And then in here, well, theoretically this should be an exception, but for now I'm just gonna make a log.
That's
Same
how you
state.
handle errors around
Yeah.
here.
So to do, actually not to do. This should be unreachable. That's cool. Okay. So what other things are we gonna say stuff about? So this is not unreachable, but this is like to do,
Unwritable.
not yet implemented.
Actually, you could just say unwritable because this is std in, and we're in the right syscall. You can't write to std in, so
No, but
that's
it's not
just
yet
wrong.
implemented because this should be throwing exception. I'm gonna do that later.
That's fair.
Okay, then we're gonna do the thing that we actually want to do, which is to call the syscall. Oh, Margareta, could you check if the foundation already comes with libc?
Uh, if it really comes with libc, what do you
Yeah,
mean
like,
libc?
yeah, libc, like you know this.
Oh, yeah. Oh, right. Yes, it does.
Okay, so
Yes, it does.
that works.
If
Nice.
it doesn't, you can import the UniSD. Our thing
Yeah,
would only work on, yeah.
yeah. And then we're
But
gonna
Import or
just copy
include?
this.
Because
include.
right,
That's just a C
include.
sheet, right? So you can just
Okay.
include.
Yeah, it's include. So it actually says a return value. On success, number of bytes written is. This is so weird. Every time I read C stuff, and the return on success is the number of bytes. I'm sure back in the day this kind of return was useful, like, but it is still weird. Uh,
You go laughing, but I was parsing the Postgres protocol, and they do that because otherwise you lose the amount of
no, like
bytes
I
you
said,
have.
I'm 100% sure they utilize that fact, but it's still weird. Uh, so
Why don't you put that in a local variable? Because it would be nice if we actually returned the error into the data stack in the VM as well.
Ah, that's very interesting. Good call. So let's actually do that. So this is gonna be um, bytes written there. Cool. Then we're gonna ask if bytes written is less than 0. That means we got an error. So again, for now I'm gonna just put I don't know, error just for now. But I'm gonna actually add a to do here. Return error code in the return stack. Else, else we did great. So actually that's about it. The side effect is already done. Yeah, the side effect is already done. So
And then we wanna
now we're gonna do the thing. So this is gonna be std out. Oh well, actually this is the right device ID. But this needs to be like this is a pointer, so this needs to be like this, I think, or something along those lines. Maybe it's actually better to just for now, just because of Objective C weirdness, just put the file window here. So the buffer count, you're gonna only print a number, right? So that is the size of an uint32, right? Am I right?
yeah.
So that's the
Um,
counting bytes. So that means it's always gonna be 4 for now.
yeah, actually the count is the next argument. The middle argument is the pointer to the buffer.
Yeah, that's true. So this is a pointer to. So this is already this, supposedly, allegedly.
Uh, Not really. Write content is a reference to a. It's actually a reference, right? Isn't it?
Yeah, it's already a reference. I need to pass a reference there, no?
But then, but then you are treating the number as a string of length 4. That's not quite what we want, is it?
No, I don't think so. Yeah, probably this is not
Yeah.
gonna work because of the difference between references and pointers. The Objective-C references and whatever the difference is of that to a pointer.
No, no, no. The problem is not that. The problem is you need a pointer to a buffer, a byte buffer, which contains text, presumably. And you are passing a pointer to an object that represents a number, which is different from a pointer to a string.
I agree.
You need a pointer to a string, essentially.
Yeah, but we don't have a string. We don't have a string. How are we gonna do that? We're gonna convert the integer to a string?
For now, we can do that just so we can actually see the thing working. But we'll have to do something about that, probably.
Yeah, but how? Okay, so you're basically saying that we need. I think I see what you're saying. We need to go to whatever. I'm doing that already. In at some point, I'm converting a string to an integer. So maybe there is a easy way. Yeah, here. Right. So this is how I'm doing that. So I'm transforming that to a string value, supposedly. If that's a thing, I don't know if that's a thing. Um, yeah, we're gonna copy that, and what you're saying is we're gonna have something like an ns string, which is like um, content, string content, and then we're gonna do something about that. So maybe write content, and then this is gonna be string value. I don't know if that's a thing. We're gonna have to check that out. Um, then we're gonna put string content in here, and we're gonna have to do something about this, something like size off, but this is C. I don't know how to do that in here. Objective C. So I think it's something like length. Is this? Yeah, this is set to objective C. Thank you. I don't want to see Swift stuff
Why
not?
I think
because it confuses me. Yeah, it is length.
I think you have to call the string method on the string content to actually get a C string back.
Where?
Like when you're passing the string as an argument to write, I guess.
You need to pass. You need to call something here. Is that what you said?
Yeah, you need the string inside of the string content, basically. Because like the NS string is not necessarily gonna be represented the same as an actual C buffer, right? There may be a header in front of it or
Oh,
something.
here. C string using encoding. Actually,
I
there is also
wonder.
there is a section called getting C strings. Awesome. Awesome.
I mean, that kind of works, I guess. Like my main worry is that if the pointer to the NSString object has some kind of header before the actual text that we're
Mhm.
interested in.
Yeah. Let's actually ask Google Objective C string to C string. Yes, kind of like that.
Probably has some
Oh, it
accessor.
uses a method called UTFS string, like
Hmm.
directly. That's very interesting. So in here, I just put that apparently, and this gives me a C string. Const char.
Not quite, because the write content is not a string yet. It's an integer.
Oh yeah, so I need to convert this first. That makes sense. So like a string value. Okay, I guess.
Okay, then you can just pass the string
Uh,
contents and then.
and then this is gonna be size off, given that this is a C again. Uh, size of
No,
string content.
actually it would be a stir lang of string content. Size of is for types, not
Can't you use
values.
size off for the size of the strings? Are you sure? Oh no,
I'm
I
pretty
I am
sure.
sure. Strlen
Yes.
like that. I guess. Okay, let's see if it compiles. I don't have very much faith on it, but let's see.
By the way, my Lisp works. Yeah, I just can't create functions.
And it's compiling to .NET.
Yes, it's running.
That's
I
impressive.
discovered there is a problem, by the way, on .NET. Uh,
There's what?
there's a problem with the reflection library to emit opcodes that right now it doesn't allow you to save the opcodes, like to dump it to a DLL. So you have to run it on memory, which sucks. But well, it's still compiling. They're working on fixing the option, but well, I was kind of unlucky.
Oh boy.
Maybe you should get rid of the at sign in front of the.
Here?
Yes.
I don't know if that's the problem. It compiled. I don't know if that's fixing the problem, but it compiled. Uh,
There, it printed a 4, apparently.
that's wrong.
It is wrong.
That is very
It
wrong.
is wrong because we forgot to actually dereference the pointer like to the VM memory to grab the number that it's actually pointing to.
Oh, wait.
Yeah, see, it
Oh
printed a
yes, you're
4.
right. You were totally right. I was print the one is the device ID, and it actually worked. It did the syscall, but it's actually doing 4 instead of 69. Okay, we need to dereference the shit. That's exactly what you said. So how are we gonna do that though?
We
Hmm.
grab the memory, we grab the RAM from the VM, and we just do a lookup in the RAM
Okay,
at
I'm gonna
address
copy
4.
paste. So where is the pop? So not pop actually. I want something like that uses
Load. You want
memory.
load.
Yes. Load, you said.
PC
Uh-huh.
fetch work as well, I guess.
Okay.
Just memory RAM, self dot
Where?
memory RAM, object at index, and then writes content, I guess.
Okay, so it's gonna be write content, and then in here value.
It's broke. That's amazing.
Yeah, eat a broke. Okay, so let's add the debugging crap. Where is my debugging thingy? Print. Yes, that's what I want. Print state.
Well, that's a wonderful debugging experience.
Yeah, it's very fine. Print state, and that's it.
There's a talk with Don Syme where like instead of using the debugger right to do stuff, literally just pipes something to a function, a lambda, that picks a parameter, pipes to system console, write a line, and then just like passes through, and that's his debugging live.
Am I going crazy?
Well, maybe
Like,
I
what the
can
heck is going
see
on?
I can see there with trash.
Yeah, so apparently it is trying to use whatever this is. So I think the conversion between ID and a value went wrong. But how?
How did you access the ID and the value?
We are just doing a lookup on the
Oh, I
memory.
think I may have possibly seen the
So
problem.
this is
Okay,
gonna
you are.
be write content. I want to see what the heck is that.
I think I see the problem actually.
Tell me. It is 4.
See, you are grabbing the right content, which is a pointer to an object that represents a number, but is
Yes.
not actually a number like a C number. And then you are using that pointer as the index instead of an actual number.
I don't follow at all.
Writes content, object at index writes content. It should be object at index writes content integer value or something like that.
No, but write content is already a 4. I just tested that. It's already a 4.
It's a pointer to a value that represents the number 4. It's not actually a 4.
Ah. Hmm. Okay, I don't know if I understood what you said, but you're saying to add an integer value here, right?
Yes.
For me, that still doesn't make sense. Because for me, it should already be 4. And it's still wrong. It is still wrong. So for me, this 4 is already the right content. I don't think this is just like doing an automatic dereferencing and showing me the 4, which is pointing to. I really think this is already.
One more thing, the value that we're printing. Okay, now we're taking the integer value of that and then calling
That's
string
weird.
value.
Why do we need to do this? I still don't get. For me, this is still like this. As we did with the load, right? Oh, but the load is. No, but this is not the one. I want the load. Where is. Oh, this is the parser. That's not what I want. Yeah, here. Load. Yeah. So I think it should be. Oh, no, but we are doing the conversion that you just said in here. Which is weird. Why do we need to do that in here? Hmm. That's sus. That's sus.
Because we're not doing it above, is why.
Okay, we can actually also add. Oops. A value here. Oh yeah, it's grabbing garbage. That's interesting. The 4. How is that possible? Because we do have like 0, 1, 2, 3, 4. How in the balls it's grabbing this?
Uh,
How it is doing that? That's not what I want. Yeah, that's what I want. So when we read from the memory,
I
we
think I
also
see. Real quick,
convert.
go back to the print. I see the problem. It's actually the NS log. You're logging the value, which is an actual integer, as if it were a pointer.
Ah, okay, but then do you remember it is this LU?
LU, yes.
I have no idea how I remember these type of things. Like
Oh, by the way, can you go on
69.
the
What the heck is going on?
flake nicks? By the way,
Yes.
let me see if I can help you with this beauty. Go down.
Mhm.
Okay, can you copy this build part?
This,
No, the entire build.
this.
You can change this. Do the following. The output, put a, like you see line 49 on the end of it.
Yeah.
This enormous line.
Yeah.
Go to the end of it and do a ampersand, like after this.
After.
No, after, yes. Ampersand and then double ampersand, sorry. Double ampersand. So it's synchronous and then you do dot slash no, sorry, output slash and then what's the binary that it generates? I don't
Chime.
recall. Chime. So that's it. Oh, you forgot the at sign. And why is it all together, Lemus? Just separate, man.
Like
Yes.
this.
Yes.
Mhm.
Now,
Wait a second. I really want to go to know how we are printing 69 and we are printing via this is called the number 4. Wait a second.
Because now we have the opposite problem. You're taking an integer. Actually, it's the same problem. You're taking an integer, treating it as a pointer to an object, and trying to call the string value method of that object, which obviously is not going to work because it's an
I have
integer.
no idea what you're talking about.
Like line 19, you have to get rid of the integer value, and then it will work. Yeah, get rid of that
whoops.
layer.
Yeah, yeah, yeah.
Get rid
I
of that
saw that.
layer of brackets as well.
Yeah,
Yeah.
I still don't see why we need to remove
Also,
that.
the type is not an integer anymore. It's an ID.
Is an ID, right? Marinho, are you there?
creak,
Hello.
creak. Oh, wait,
Oh,
wait,
I
there are
thought it
sounds
was.
for this.
I thought it was me.
There you go.
Yeah, there are sounds. Ah, there are sounds. What the heck is going on? Like, why is this not working at all? That's a very good question.
Oh, he's back.
Marinho,
Yeah, connection decided to drop.
could you explain to me why we had to remove the other integer value? Because to me we still need it.
Because when you have the integer value, what you're doing is you have an object pointer. It's a pointer to an object that represents a number,
Yes.
and you are grabbing the underlying value of that number, like as a machine with integer.
Yes.
But then that's no longer an object; it's a number. It doesn't have methods, and you're trying to call the string value of a number.
Yeah, yeah, because the ns integer has this method, I believe.
Does it though?
Well, it didn't work regardless, so I don't remember. I don't know, but
But
for
it
me it
did
should work
work.
just
It's
fine.
it printed it printed a 69. We
No,
don't
it
have a new
didn't.
line set.
No, it
It
didn't.
did.
No,
The
it
next
didn't.
line. The next line.
The next line is a 4.
The beginning of the next line.
Oh, the D69.
We're not printing a new line, Lemos. It's gonna be glued to the next line, of course.
That's interesting. So, should we add a new line for the user or should we just. I think we shouldn't because when we add string support, the user is going to have to add the new line himself.
Questions for later. It works. That's the
Questions
point.
for later. Uh, okay, so let's see if this works. Yeah, there is the 69. What the heck is with this 4?
I think we're printing it
Oh, we are
somewhere.
printing the right content here. That makes sense. Okay, so theoretically there shouldn't be a 4.
You should add a halt instruction to the program.
Ah, yeah,
Um,
that's true.
aren't we gonna expose the that as the return of this expression of this syscall?
We
This syscall
should.
is only side effectful. We're not gonna do anything about that.
We
Aside
should
from
push the
putting
bytes.
the error into the.
We should push the bytes written to the return to the data stack so
Yeah,
that
just like the C one, right? That's
just
what I
like the
meant.
C1, yes.
Oh, that's very interesting. I didn't think of that. Okay, so let's do that. So, uh,
Uh,
let's see how the heck we're gonna do that. So we're
Oh,
gonna
and
do.
then so one thing in this case, you don't even need to handle the error, right? You just return it.
that's
Yeah,
true.
that's true. That's true. That's actually really true. So we are basically saying, you, the user, you gotta have to handle
Yeah,
this shit. Who
screw you.
cares? Okay, so does anybody remember the syntax to do a push? I always forget this sort of stuff. So push.
You
Yes.
just push.
Yes. Okay. So it's just this. I believe this is the syntax, or maybe it isn't. Maybe it is actually
No, no,
bytes
no, 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 no. You need
written
you need you need
integer
the at
value.
sign. You need the at sign. It's backwards, Lemos. You have an integer. It does not have methods. You have to turn it into an object. You need the at sign for that.
Oh, I think you're right. This is what converts it to ID. Yes.
Yes.
Okay, so then we're gonna do that, and then who cares? Basically, basically.
Basically,
Then we're gonna put a halt. So let's actually do that. Um,
after
so
the syscall, yeah.
halt. I forgot semicolon.
Okay, it printed the 69 and we wrote
Oh,
two
that's right.
bytes,
That's
which
right. Because this is a
correct.
string with 2 bytes for now. Okay, that's actually pretty cool. But we should add a to do here.
We need string
So
support.
add support for strings. Right now only numbers work. Which actually begs the question: what if I put 34, 35?
It should work, I think.
Yes. Yes. It does indeed work. That's awesome. That's very cool. Okay, so let's try to do what you guys want. Do you want to implement the order? The hmm. Actually, do we need this if? Because
Oh,
if we
probably
swap
not.
this with the right device ID, it's generic for all of them.
We probably don't need the if.
That's very interesting. So if you try to do something wrong, like if you try to
It's
use a
just gonna
device that it's not,
it's just gonna return -1. It's also gonna set the error nodes, but we don't check that inside the VM. We don't have a convenient way to do that actually.
yeah, that's true. Okay, so let's actually put this code here and let's actually swap this. So this needs to be an integer, but that is a pointer. So we need to dereference that ID, right? So I think we need to do the integer value
Uh,
trick this time, right, Mari?
yes, we should.
So it's right device ID integer value. And then we can get rid of all of this. I'm gonna put, yeah, I'm gonna put this here. And then we can get rid of all of that. Okay, that's not bad. That's not bad. Yes. Let's actually try to do shit. So let's put 3. Okay, that is -1 in 32 bits, right? Or 64, I don't recall.
That's a very big number.
Yeah, but
But yeah, it should
that's a
be.
-1 for sure.
It should be.
Yeah, that's a
We
minus
should.
one.
You know what we should do? Currently, when we halt, we print the value at the top of the data stack as an unsigned number, right?
Yeah.
We should change it to a signed number because that's what it actually is.
Okay, that's a good idea. Let's do that. So halt. So how? It's not LU then. It's gonna be something like L.
L, just L, I think. I think that's that's not
I don't
correct.
think that's quite right.
That's not correct. Um,
Yeah, that doesn't seem right at all.
I wonder if it's Li instead.
Okay, I have no
Um,
idea why, but that's okay. It is. How did you know?
because integer versus
Wow.
unsigned integer.
Okay, that was a little bit. I would never think of that. That's okay. Let's do read. Let's do read. So what do we need to care about when reading? What do we need to care?
Oh, we need to pass a pointer to a buffer that we read the value into.
Oh, that's very okay. But then we're screwed because we don't have we don't have that abstraction.
And you laugh.
Ah,
Of course. How cool. Okay, so here's the lesson for today, folks. You gotta have strings. You gotta have strings, man. There we go. That's hilarious. Okay, let's see. Man. Okay, you need to do the same device thingy and the buffer and the count. Attempts to read up to count bytes from file descriptor into the buffer starting at buff. On files that support seeking, the read operation commences at the file offset, and the file offset is incremented by the number of bytes read. If count is 0, read may detect the errors described below. May detect.
May.
That's sus. In the absence of any errors, or if read does not check for errors. What?
If it's not zero, account if the count is not zero, basically.
A read with a count of 0 returns 0 and has no other effect. Yeah, but what about this part? Like, what the heck they are talking about? Uh, that's okay. Okay, so what is the convention for the file descriptor for reading? Is this the same thing as the std out as the write?
Yeah, you just read from file descriptor 0 because that's the std in.
I see. Um, okay, so for now, we're not gonna provide the user the ability to have the data that he just read. Let's just print it to the terminal because then when we implement the strings support, then we're gonna fix both. So that's okay. Um, so with that in mind,
Yeah,
we're gonna have to read the same thing here. We're gonna do this first. Yes, it's return size t. So this is gonna be read device ID. We're gonna have to have a buffer of some sort. So I guess we could do. How do you initialize an empty string again in C?
Char, and then you put nothing.
and it doesn't have to be. I'm not. The problem is you're initializing space for a char pointer, not an actual like buffer that you can write things into.
Yeah, wouldn't this be something like this? I remember something like this.
Well, yes, that's setting the size.
Yeah. So then we would, instead of doing a write, we would do a read. And then instead of doing string content, we're gonna do, well, we're gonna do string content anyway, actually. And this is actually still the same thing.
We actually have to pass the address of the string contents instead
Yeah,
of the actual string
that's true.
contents.
We're not gonna do anything about this
And
yet.
no, by the way, the stir len of string contents doesn't actually work because it's an uninitialized buffer.
So
It
it's
should
10.
be just 10, yeah.
Yeah, that's okay. Then we're also not gonna do anything about the stack.
We
Uh,
should return the return value of read. We should pass it to the data stack.
we should pass that to the data stack. That's true.
Except
Add
we
support
rename
to
it to
strings. The user should have access to the red content. But for now, we're only
stack
gonna log that. Printf. So this red content, and then this is gonna be string content.
address of string content.
Address, yes. And that reminds me that
Actually,
maybe.
that doesn't quite work because the final byte may not actually be a zero, and C strings are dumb.
Let's try anyway. I want to see what the heck is gonna happen. So
Okay,
let's
it's
make a
gonna break, but
program.
okay.
Read syscall. Let's go. So what the heck we're gonna do in here? We don't have to push anything actually. Oh no, we
You
do
just
have to
have to.
push some things. Yes. Um, yeah. So theoretically speaking, in the future, this is gonna be like read syscall content. This should be std in device, and this should be read syscall, and then we halt. Um, that's wrong. Actually, I don't remember.
Uh,
It is 0.
we're actually missing from both syscalls the final argument, like the number of bytes that we expect to read or write. That's something we'll have to change in the future. Once we have proper strings.
Oh yeah, that's true. That's true. Read syscall is the 0 syscall, and this should be the reference to what do you want, where do you want to store that shit?
Yes.
Where do you want to store that shit? Actually, what you said, then that's the question. Where are you gonna put that? So I think what you're saying is like read size, and then we can do something like size.
Um,
So
I
this is gonna be
mean,
this
if
one.
yeah, if we go with the idea that we are going to use fourth style strings, which have the size inside of the string as the first like word in memory, then we may or may not want to pass that argument for writing, but we definitely need it for reading.
Cool. So let me actually pop that. So we first pop the device ID, then we should pop the size. So read size. Then we pop the content. Then we pop the content. Then we're not using these, right? We're not using these right now because we need strings.
Not I don't want to hijack the meeting, but Maria, do you have any any reference to compiling a? It doesn't need to be a functional language, but to compile a language to a stack-based uh VM.
Compile a language to stack-based VM.
Yeah, I think Lisp to a stack base would be a better bet
Yes, it could
because
be
doing
because
C to stack is very easy. I think.
I could make work, but it's in a very clunky way. So I wanted to see how like how I can improve and do it properly. Because I'm not being able to add like I'm having a hard time doing a conversion to a stack based approach on like loading variables, storing variables, and
Yeah,
also on the
yeah, and I totally
uh
understand that pain.
yeah, this is very
Yeah, basically, no,
weird.
nobody's like you, Marinho. That's
Like
basically the
right
conclusion.
like right now, all that works is I can make ifs, so I can make branches, like a branch if equals whatever. I
Yeah.
can I can print, so I can call the .NET CLR like to a certain extent if I add the support for some functions, and I can cast types. So, for example, if we are doing a division of an integer with a float, it will pick a float, for example, and
Boys,
doing an arbitrary application of primitives, like for example plus, and then it passes a list of numbers. You see, so I can only do that for now, but defining a
Oh,
lambda, I'm having a hard time.
okay. Um, the
I have no
lambda
idea
it's
what happened. What the heck is this?
That's bytes, right? Just bytes.
No, no, no. I don't know. Well, probably they are bytes, but who is putting this?
Well, probably you're doing read, so that's weird.
No, no, no. It's not weird because I'm printing what I read, which is correct. It is test. But I don't
All
know
right.
if this is supposed to be a bug with the new line.
Oh wait, no, you're not printing the. You're printing string content, which is on the buffer that you passed to it, right? Can you
I
put the?
told you,
Can you print the bytes written?
I told you, man. We need to put a null terminator in that buffer. Right now, it's just have you just have 10 characters uninitialized, and we have no idea what they will be until
I have a
like
question. Wouldn't this work?
I mean,
uh,
that's already the null terminator is just null, right?
it will fail if we manage to actually read 10 bytes, and the 10th byte is not a null.
Yeah.
I want to see what happens with that.
Wanna see? Oh, by the way, man, you don't need to do.
Yeah,
Wait, what?
it worked.
What?
It worked. Thank you,
Yeah, because
Zanzi. Thank you for the many C videos.
yeah, but that only works because you read 8 characters. If you try to write a
Yeah.
longer string, it's gonna fail again.
Yeah.
Is this an emoji? What the heck is this thing?
Yeah, that's Unicode, right? It's trying to convert a byte to something.
Oh, okay, so this is what Marinho said. So if you have 10 or more, it's gonna override the 0 and then you are completely done.
If you have 9 in that case, right?
Yeah.
Yeah, you have to bump down the number of bytes you are reading
One, 2, 3, 4,
to
5,
limit.
6, 7, 8, 9.
There's the new line as well, man.
There's a news line as well, so it should needs to be 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes.
By the way, I added the I told you to add the thing on the build, so you wouldn't even need to keep using the dot result being chime blah 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 all this
No,
time.
I didn't. Are you sure?
Oh, right, but you have to
Oh, you
pass
need
the
to add the
samples.
flake, right?
Yeah, but you need to have passed the samples as well, right?
Yes, I need to pass stuff.
We're just
Uh,
calling the binary, so just keep using that way.
right. So I'm trying to look for a reference specifically on compiling to a stack-based VM. But the basic principle is that um,
Why don't you use? Well, I have a reference, but I want us to finish the today's goal. I can say I'm gonna send you the link that I know Mageta. That's fine. So we have read and writes. What else do we want, people? What else do we want?
we have read, we have write.
Like there, as we saw earlier, Marinho, there's like an infinite amount of syscalls.
Yeah,
Okay,
Linux
that's
has
a
a
lie.
lot
There's
of them.
300.
Yeah, Linux has a lot of them.
So which
Uh,
ones do we care? We have two. We can make whatever amount.
I think we let me see of what would be useful now.
I think open and close may be useful.
Oh, I thought we had close already.
No, we had
For
read
like,
and write. We don't have open and close.
oh, so you can't make new file descriptors right now.
Yeah, yeah, but that's what we're discussing. Do we want that?
Well, yes, right. That's file support. That makes you more useful. But
you,
is there any
you
other thing that is actually more useful than that? Let's see.
fork and exec maybe would be fun.
Fork and exec would be like for like
Yeah.
concurrency. That would be
And,
very interesting.
to spawn processes, right? That would
Yeah.
be. Oh, the semaphore. Probably search for a lock. I think. How was the system call for that?
Yeah, F lock.
I don't know if it was F lock. Search for semaphore. No.
Yeah,
Sema.
Or is that's a C library? Never mind.
yeah. No, semaphore is what it's called on Plan 9. I'm pretty
Yeah,
sure in
play nine.
Linux.
It's semaphore.
Oh, it's semctl probably because
Sem.
abbreviations.
Oh yes, semctl. Let's go. Yeah, semaphore control operations.
Yeah, that'll be very useful as well.
So there is a dot dot dot.
It
So
looks
let's
like a
actually try to
JavaScript definition.
discover. Let's actually try to discover what are the things that we need to pass.
A lot of stuff apparently.
Yeah.
Yeah. Do we need to pass it all? Like, can't we just pass these three for now? Like, the description here is assuming that you're only gonna use the first three.
That's probably a very variadic function
Oh,
actually.
three or four, depending on CMD.
Hmm.
When there are four, the fourth has the type union semnum, and the calling program must define this union as follows. Oh fuck, we're gonna have to translate this to our thingy. That's interesting. Like when compiling, these will probably be some sort of like byte manipulation. The SEM ID DS data structure is defined in blah as follows. Okay, for now, let's just go with the version
Um,
with three.
Actually, it doesn't need to be a. We don't need to get too into byte manipulation because apparently it's either an integer or a pointer of one of those types. It's a union, not a struct.
No, but it has a struct in the middle.
But it's a
Actually, two
pointer to a
structs in the
struct.
middle. Yeah,
It's a pointer, but it's a pointer to a struct, not
yeah,
an
that's true.
actual.
That's true. Anyway, I'm in favor um, of implementing the version with three today. So let's go. So we're gonna go to syscalls here.
I have no idea what that's supposed to do, by the way.
Well, we're gonna read it shortly. So syscall samctl. What is the code? 66. It is the 66. Okay. So now we can go to here, and then we're gonna
It
make
will be
a.
it will be interesting having to convert this to run because it's not gonna run on macOS, right?
It's not gonna run in
So
macOS at all.
yeah, so we're gonna probably have to convert and adapt the system calls
We're probably
to
gonna use
Mac.
like hashtag if def and
Hmm.
and else like with the macro for different operating systems and stuff like that. Which is actually gonna be kind of cool because ideally it's gonna be only one line of like the different syscall.
And BSD as well. That will be interesting to see.
BSD.
Yeah.
One day, Chime is
Yes.
gonna run on Plan 9. That will be the day.
I think BSD would be easier because it's I suspect Linux copied the basic system calls and then just started spamming because it's monolithic.
It's so freaking cool that we can just mess around with the evaluator and the parser doesn't care. That's cool. Because again, we are only adding a new instruction, so it doesn't need the special support. Sim CTL. So now we read what the heck this is supposed to do. Uh, oh, okay. So this is a combo instruction. This is only for controlling it. You need another one probably to create one.
Probably same up and same get, I'm guessing.
Okay, so these ones comes in a package. Returns the system v semaphore set identifier associated with the argument key. Okay, I don't know if that's what we want. Um, each semaphore in system 5 semaphore set has the following associated values. Performs operations on selected semaphores in the set indicated by SemID. Yeah, but how do I get my SemID, my friend? How do I get that? There's only these three with Sem as a prefix. That's kind of sus. What if I want to create one? I think I'm already going to a table that we don't care, which is like different architectures. How do I create a thing? What is the return of this thing? Yeah,
It's
so it is
magic.
this one. On
It's
success,
magic.
semget returns the semaphore set identifier, a non-negative integer. On failure, -1 is returned and error is set to indicate the error. Yeah, so this is the one. And so this is a bad name. Semget. I would just go with semcreate because
Wow, it's
get seems that
getting a
that
semaphore.
I'm getting out of a pool of IDs.
You really thought that would happen?
that question, that question was great. You really thought that would happen?
Of course not.
Of course not. That's crazy. Okay, so I think we should implement semget first.
Man, I'm so out of resources that I think I'm better off just going to watch a live stream of Zozin coding something on Stack.
Uh,
Um,
you want to watch him doing stack-based stuff?
It's not that I want, it's just that I don't find material.
Yeah, so
That's the problem.
ironically enough, what I was about to suggest to you is there is a VM in a programming language that he did, but I don't remember the name.
Ah, man.
I don't think it's Bada.
The problem
Uh,
is like looking C just to I wanted to like actually see theoretical material, not just see an implementation. You see, that's the problem.
yeah, I don't.
oh,
The
if you
only
want
person that can
theoretical
help you with that is
material,
Marin.
I have a decent reference. It's not specific to stack-based VMs. It's actually about a scheme implementation that compiles down to C, but it should
Okay.
give you some ideas on what to do.
Yeah,
Um,
C's like assembly, I guess. Yeah, the problem of assembly is that it's not really stack, right? So that's part of the problem.
but,
But I
but a
think
lot of
the yeah, go on.
yeah, but a lot of scheme implementations are stack-based internally, even if they don't use the forth-like, data stack, return stack thing.
Mm-hmm.
Because Scheme has to support first-class continuations, and to do that, you need to reify the stack anyways. So, let's see, where's the article? This is about the garbage collector.
I'll go have dinner and I'll be right back. And
Sure.
hopefully I
Okay.
will not sleep going from here to there. I'll be right back.
Okay. I'm gonna
Okay, I'm
try
going
to
to.
with Marin to implement the last two ones, and then we're gonna finish for today. Whew. Are you ready, Marin? Are
Uh,
you ready?
I guess.
So sem get. Okay, so let's do the get first. This file is gonna get bigger and bigger with time. Bigger and bigger with time. So the first question that I have for you, um, what are the things that we're gonna have to pop? We're gonna have to pop the key, the ensems, and the sem flag. What is a key T type? It's a very good question.
I have no idea. It's probably a number, probably, but it could be something else.
Okay, so the first thing that we're gonna pop is the key. So this is key. The next thing is the ensems and the sem flag. Ensems and the sem flag. Cool. So actually, boom, boom. Okay, so now we're gonna pop this. Uh, this is an integer. And what is the return? Oh, the return is actually the ID. So this is sem ID, which is kind of cool. So sem ID. Should we put these things on the data stack and not actually in the return stack?
We should. The return stack is for return addresses. It's not for return values. The return values go in the data stack because they are data.
Oh yeah, that makes it's for return addresses. It's only for calls then.
Yes, only for calls.
Okay, my bad. Um, mm, okay. Let us continue. So the thing that we're gonna put in here, it's not that. We're gonna put this. Then we need to discover what the heck are these things, man. We really need to discover what the heck are those things. And we also need to discover what the heck, how to make a C integer. So ns integer to C integer. Let's see if this works. I don't know if he's talking about Objective C, but oh, you just literally cast it. Tada! Sure. So in that particular case, um, so we first convert that to an integer value, and dereferencing the ID, and then we convert that to an int.
We probably want to do the same thing to the key as well.
Yeah, but we need to discover what the heck is a key T.
Mm,
What the heck is this? And this is wrong. Boom, boom, boom. There we go. So what the heck is a key T in C? Thank you very much, Google. Wow, that's a very bad website. Okay, so let's actually go to Stack Overflow. What is the point of having key T if you will be the key to access shared memory? What is that type? Okay, I want to YOLO it. Do you want to try that out?
you only live once.
Yeah, so we're gonna just cast it and see if that works. And see if that
What could
works.
possibly go wrong?
That's a very good question. Okay, so let's actually make. Maybe we should actually make a subfolder. Syscalls, and then here, syscalls read syscalls right. Yeah, much better. Much better. Because as we add more and more examples, we're gonna have more and more. So samget gff. Cool. So let's actually copy this. Let's throw it in there. So we need actually three parameters, right? We need three parameters. We need flags. So let's actually put that at 0 because we don't care. Actually, maybe we should read. So that's the wrong one. It set identifier associated with the argument key. It may be used in order to obtain the identifier of a previously created semaphore set. When simflag is 0, the key does not have the value IPC private, or to create a new set. Okay, so you may actually want to create that as, but we're gonna put that as 0. That's fine. A new set of nsim semaphore is created if key has the value IPC private and if no existing semaphore set is associated with key. If simflag specifies both IPC create or the other one, and a semaphore already exists for key, then semget fails with error no. What is nsims? That's a very good question.
It's something, probably.
So you can create more than one semaphore, so like a new set of nsim semaphores. So you can actually use a single key to manipulate multiple semaphores. Why in the fuck would you want that? Am I getting this wrong?
Honestly, I'm not sure because I never actually messed around with semaphores before. Um, my favorite concurrency primitives is actually compare and swap, so I'm kind of biased in that direction.
Yeah, you're not that old. That's basically what you're saying. I actually mess around with semaphores, and probably not this specific library, but I did that already in the past during university. Long, long time ago. Long, long. I think the number of semaphore. Yeah, this is clearly grabbing the argument, something that you pass in the argument, command line as an argument, transforming that to an integer, and so that is the amount of semaphores maybe. That is still sus because why would you want that? Why would you want that? Look how descriptive. The third command line argument is an integer that specifies the m-sense argument. Ah, I don't want to know that. I want to know what is the semantics.
That's, you
Yeah, it
see,
is the
this
number of
I'm,
semaphores.
yeah, you see, this kind of complication is why I suggested fork and exec.
No, it's not a complication. It's just that we don't
I'm
understand
back.
the use case.
Hello, Magetta.
Magetta, do you know
Mm,
why would you want to be able to control multiple semaphores using the same key?
the same key.
Yeah. Why in the balls would you want that?
Wait. First of all, what is the key? I don't recall this API.
Yeah, the key
Uh,
is basically what you're gonna be using to like have
because
access.
the only thing I recall, like the difference between a semaphore and a mutex, right, is that the mutex is just two states. The semaphore you can have multiple states, right?
No, no, no. Yeah, but let's go into the difference between
No,
those.
I know, but I'm just trying to remember because I don't exactly know this API.
Yeah, you have a
So
key which is
system call,
basically an accessor to your semaphore. But this
right?
API provides you a way to have multiple what they call a set of semaphores, a set of semaphores.
Oh, you maybe because you would want to segregate groups of processes. I don't know.
Segregate groups of processes.
Like think of like you spawn like a program, for example, it spawns multiple processes, right? It doesn't handle everything on the parent. So it would spawn a set of children to handle one specific context, and then it would just like sync over that semaphore or the group of semaphores, right? Dividing
Mm,
over them.
okay.
I don't know. I don't know if that is the case, by the way.
Okay. No, no, but like I was telling Marin, we don't actually care how this is going to be used. We are only implementing it into the assembly. Uh, so
Yeah, but
nsems.
I don't know, man. If we don't find any useful, like for example, I don't know why that is useful. So what we do with that? Should we should we still implement that? I don't think so.
I think that having a few ones that we know are very useful in general, like semaphores and mutexes and fork,
Let me see
even
here.
if you're not going to use
See
them,
get example.
I think
System
it's useful.
5. System 5 QB.
And
It
then we
could
also need a
be
key, right? We
all
also
of
need
this could be the Xerox Auto.
so key, and we're gonna put something
Key
like
is a unique identifier if any process wants to connect to the queue, it would have to use the same key. As key is a long data type, you can use it any integer to set to the queue to the key. You can also use ftoc, known as file to key. The function accepts two arguments. Who cares? Uh
there. So you put them in reverse order, right? So yeah, so it's like this.
oh right, okay. I think I got it, Lemus. Oh right, so people use it like this. They put the name of the file, the resource you're opening. So this ftoc, which I think is another system call, uh, or is it? No, I don't think so. That's an IPC thing. It receives two arguments: the file path and an ID. So with these two arguments, it will create a unique key that a program is trying to access. This queue should have the same parameters. So it basically gives a way so people can get multiple instances uh of the same thing.
mm.
So I don't think you are creating multiple semaphores. You're creating only one.
But
You're
what
just
is the
sharing
semantics
it.
of saying a set then? It is written in
Well,
documentation. It's a
it
set.
might be a set, but you can still share the things, right?
Yeah, and there's another piece of documentation saying that nsems is less than 0 or greater than the limit of number of semaphores per semaphore set. So this is really, really strongly indicating that you can have multiple semaphores in a set. Which again, I don't have
Because
a
it
use.
makes no sense to have
Yeah,
multiple
yeah,
of
that's my
different.
point. Like, why would you want that? But
Like
again,
why?
I'm not a C
Here's
developer.
I mean, it might make because since the semaphore is like a queue, and then you have different amounts of uh thing states inside of it, right? I don't know the correct term. I don't recall that correctly, but you might have like three states, and the other you might have two. So, but you are referencing to the same place, so you would want the same key, maybe. You see?
Mm,
That's a guess. I don't even know. I'm not a C
mm.
programmer, thankfully. Uh,
Okay,
yeah.
that should be it. Um, okay,
Magetta,
we
I
have a
found
problem.
you
We have absolutely no
some
idea what to
references,
judge.
but I'm still looking for more to help you out. None of them are
All right.
specifically to
Thank you.
stack machines, by the way, but they are about Lisp compilation, like more in general, so they should help you at least a little bit, you would think.
Oh, that's awesome,
Wait,
man.
this is
Thank you.
C. If I don't delete the semaphore, is that still running my machine?
Well, yes. I.
Ah.
What a silly question.
That is still running. Okay, having one useless semaphore, but it worked. Wait, actually, did it? Did it work? It printed
I mean,
something
you
here.
have a zombie process though.
Yeah,
You're
yeah, I
happy?
do have a zombie process, but that's okay.
You can
Uh,
kill it later.
uh, no, I don't want that. It's wrong. Oh yeah, it is wrong. Okay, so it's definitely wrong because I'm calling the right syscall, and that should definitely not be the case. So my question is how? How did we did? How did I did that? That's very weird. What is the difference between these things? Oh, I see. I did bullshit. Okay. This is this, and this is this.
The first link you sent, it's the more magic thing.
Yes.
That's like on chicken, right? I think it compiles to C, but
It compiles to C, but it has some interesting ideas. Like the chicken
What
internals.
in the balls?
There are two posts about the internals of the chicken, like data representation and garbage collector. And there's also a series of posts on the numeric tower, which may be interesting to look at later. Um, but the garbage collector and data representation ones are very helpful. Like, I learned a lot from those two
How
articles
is that
specifically.
possible? Mario, I need your help.
Uh,
Am I
sure, what's
going
up?
nuts? What am I doing wrong here?
Let's see, you're pushing the flags, the number of
Absolutely wrong.
semaphores, the key.
Yeah, you can read it now, but I think it was wrong there.
One, two, three, four literals, syscall and halt. You're pushing a 0, a 1, and a 64, which is the syscall number, right?
Yeah.
And then,
It would be kind of nice. I already told you this before, but it would be kind of nice to have a prelude with these compile things already there.
yeah, we can do that at some point. Just,
So then you don't have to check the number because that means that we're gonna have to make documentation otherwise.
yeah. Um, right, go to the implementation of the
Yeah,
syscall
but
real
before
quick.
before we check the implementation, let me just check if that was the problem. Okay, that was the problem, but it returned -1. That's very
It
interesting. So
sure
it
did.
failed. Why?
Try changing the key, maybe.
Changing the key to what? 10?
Anything else, as long as it's not 1.
Sure. Yeah, no, it's still broken. Okay, so let's
Okay.
actually check a get example in C. Thank you very much. Ah, okay, so the key is a special type. It's not like a.
yeah, that's what I read. Literally.
Maybe we can't cast because we tried to cheat, Magetta. We tried to cast it, an integer to this type. But
Yeah.
apparently we can't do that. That sucks. Okay, so how? What is the key T? F talk. Like the
Search on
great
the Linux. Search on Linux die. I think that's better. The documentation.
Linux what?
Linux die, like dice, but die,
Dice?
like die of
Singular.
death, like
Oh,
singular.
die.
Yeah,
Die.
that.
Okay.
It's like man, but I think it's better.
Okay, so on success, generated KT values return uses the identity of the file named by the given path name and the least significant 8 bits of proj ID to generate a key T type. It's not telling me what the heck is a
What is
key
that
T.
MSC, MSJ, MSG, sorry, MSG
Message
get,
get,
message get,
message
yes, thank
get,
you.
mget, shared memory
So
get.
this is generating a key using some sort of
Shared memory.
magic concatenation between a path name and a char, and the least significant bits of a char.
It
Actually,
doesn't point to the structure, right? It doesn't have a link. Search for key talk. Yeah, sorry, key underscore T on the search. You see there? And having wild memories of my professor opening this on. You know the browser links, the browser on the terminal.
Oh.
Yes, that those were his classes.
That's old. Okay, so apparently there isn't a very descriptive thing about it.
Ah, you
Oh,
can
and now
probably
there's an
click
ad.
on the types. Of course, they gotta make money.
Oh, but
Uh,
before that there wasn't.
what? Man, they used to tag the .h to some REPL.
Okay, so what is key T in C? Yeah, so let me continue reading this. The whole system, 5 IPC systems, full of bad designs.
Like this. That
uh,
design.
the only instance I can think you need system shared memory is for X shared resource image extension and perhaps other X extensions. Oh, here. Key T is usually 32-bit, and yes, you could just pick a 32-bit number yourself. But the problem is that humans are not equally likely to pick all numbers, and the chance of collision is way too high. ftalk lets you choose a file and an integer and hash the file's uh, enode number with your chosen integer, which should result in a much more even distribution of key choices. Oh, so this is for collision. So that's why they use the function. It's to prevent collision of keys. It makes sense because you don't want to have this like having collisions for controlling semaphores is bad. So this is wow. This is very that was very unexpected.
That's very sad, actually. I bet
Yeah,
Smalltalk didn't have this
chances
problem.
are it's failing because it's colliding with something that already exists.
Oh, you think it's colliding? It's failing because
The
of that?
same number. Oh, wait, did you use the same number and then you didn't disable it, didn't delete the previous one? Could be
No,
that.
before we were not running it. Before I was doing wrong with Chime code. So before I was actually calling the right syscall. So that at that time we were good.
Hmm.
But then I
Oh,
executed once and it failed because the data stack has -1. So I didn't create anything. But Marinho's guess is that the key that I chose, which is 1 and 10, those are already being used. So maybe I should put literal garbage.
Literal garbage.
Like, what are the chances of having a collision with that?
pretty high actually.
Yeah, it didn't work anyway. Okay, so okay, that's fine. Um, that's fine. So at some point, I'm gonna make that a to do, but at some point we should have the address this. So for now, I'm gonna comment this out because this is just copy pasted code, and I'm gonna comment this one out as well. And I'm gonna say is not yet implemented. And then in here, the to do should say figure out how to properly how to properly okay, one alternative is that we could extend this syscall to receive 2 extra arguments instead of the key. You provide the path once you have strings, and you provide the byte that you want, and then we call the ftorque function in here for you, so then we don't have to implement ftorque on this level.
That's an option, certainly.
use use keys for semaphores.
Yeah, you could embed it on Chime, right?
Yes, yes. We would not allow you to create the key yourself, but we would ask you for the arguments to create it for you. And I think that's a reasonable solution. Okay. Uh, okay, so today we basically, yeah, it's just a matter of extending these things now. And the thing that we discovered today, we need strings, boys. We need strings. Who would have guessed? You can make a tree-incomplete language without integers, but having um, a convenient tree-incomplete language, you need strings. That's interesting. Okay. Uh,
Uh, I mean, you